Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam and other exams related to physical science. Okay, so this is the lecture number 14 of electronics, in which I'm going to discuss Zener diode. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, and also guys, share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay, so let's get started. And meanwhile, just let me check whether I am audible or not. Then I'll proceed further. Let's start it. And yes, I'm audible, so I'll proceed further. Okay, guys. Okay, so Zener diode. Zener diode. Zener diode. Zener diode. Zener diode. Okay. So symbol of Zener diode is this. Okay. So this is the Zener diode, right? Okay. This is Zener diode. This is the symbol. Okay. And also, so if we draw the graph for Zener diode, so this is going to be like this. So in forward bias region, so current will increase like this normal diode. Okay, so this is in forward bias region. Okay, and in the reverse bias region, so current will slowly increase. Means current will be very less. Okay, okay, so current is going to be very less, and suddenly this current is rapidly going to increase. Okay, like this. Okay, so this voltage at this certain voltage, the current rapidly suddenly increases. That is called Vz. That is Zener voltage. Okay, Vz. So at this voltage, so current will be very less, but suddenly at this voltage in reverse bias. Okay, in RV, in reverse bias, suddenly it will increase. Okay, suddenly it will increase rapidly. It will increase. Okay, at this voltage, and this voltage is called this is Zener voltage. Zener voltage. Okay. Okay, so this is the one. I'll write some points. So Zener diode, Zener diode, Zener diode behaves as an ideal diode in forward bias region. Okay, in FB region. Okay, so we can see. So it behaves like a normal diode. Okay, so this is the curve for normal forward bias diode, right? So Zener diode behaves as an ideal diode in the forward bias region. Okay, FB region. And you need to understand this, guys. This is very important. Okay, the V, that V output, the V should be greater equal to Vz, mod of Vz, Zener diode. Okay, and then this is voltage regulator. Voltage regulator. Okay, and if mod V is less than Vz, that is Zener diode, Zener diode. This implies that is normal ideal diode. Okay, normal ideal diode, normal ideal diode. Okay, if VZ is less than this, or V is less than VZ. Okay, Zener diode, and VZ is known as Zener breakdown voltage. Okay, VZ is known as Zener breakdown, Zener breakdown, Zener breakdown voltage. Okay, so VZ is Zener breakdown voltage. Okay, next point is that Zener breakdown. Okay, Zener breakdown, Zener breakdown oblique tunneling. Zener breakdown oblique tunneling. Zener breakdown oblique tunneling. Okay, so what is this Zener breakdown or tunneling? Okay, that I'm going to explain. So when this diode is reverse bias, okay, in that case what will happen? If diode is reverse bias, in that case the depletion layer, okay, when diode is reversed biased, in that case the depletion layer width will increase, right, will increase in reverse bias case. The depletion layer of the width is going to be increased, that depletion layer. Okay, this will increase. So this means I have already explained the depletion layer and PN junction diode, PN junction, the PN junction. Okay, in my previous lectures you can check that. Okay, so depletion layer width increases. Okay, so depletion layer increases means the strong electric field, because it is in reverse bias, right? So depletion layer width increases means strong electric field generated, right? That's why this depletion layer width increases, right? So strong electric field generated, EF generated, strong electric field generated. Okay, so if it means the potential barrier increase. Okay, potential barrier, increase. Okay, so when reverse bias, depletion layer width increases, that means strong electric field generated. Okay, strong electric field generated, and that implies the potential barrier increase. Okay, so it means in reverse bias case the potential barrier will increase. Okay, so this means what will happen in that, if this happens, this means the covalent bonds starts breaking. Okay, so covalent bond, because the potential barrier increases, strong electric field, depletion width increases, so it means uh, covalent bonds breaks. Okay, in reverse, so covalent bonds breaks, covalent bonds break. So covalent bond break. Okay, that implies electron hole pair generated. Okay, so when so I'm explaining Zener breakdown, right? So in Zener breakdown means, so we have the diode is in reverse bias. Because diode is in reverse biased, it means the depletion layer width will increase, right? And this means the strong electric field generated, right? And that means the potential barrier increase. Potential barrier increase means the covalent bonds break, and because of that electron hole pair will generate. Okay, generate. And this means electron hole pair will generate means the current will flow, right? Rapid current will flow. This means the conductivity, it means the conductivity sigma will increase, and conductivity sigma will increase means resistivity will decrease. Okay, so this is the uh, Zener breakdown, okay, or tunneling. Very simple. So in Zener breakdown or tunneling is, so the diode is in reverse bias, and because it is in reverse bias, depletion layer is going to layer width is going to be increased, and that is increased means strong electric field generated. That's why that width is increased, right? That is increased means width is increased means potential barrier gets increased, right? Potential barrier gets increased, right, because of strong electric field, and then the covalent bond starts breaking, and as they starts breaking, the electron hole pairs will get generated, and because of that there would be more electron hole pairs, right? And inside the diode, so that it means the conductivity will increase, and conductivity increases means resistivity decreases, right? Because conductivity is uh, inversely proportional to resistivity. Okay, so this is the Zener breakdown. Okay, in this chart I have explained it. Okay. Okay. Okay, so next is avalanche breakdown. Okay, avalanche breakdown. Avalanche, avalanche, avalanche breakdown. Avalanche breakdown. Okay, avalanche breakdown. Avalanche breakdown for lightly doped. Okay, lightly doped, lightly doped. This is the diode is lightly doped. Okay, so this is avalanche breakdown. So what is avalanche breakdown? That I'm going to explain. Then we'll solve questions. Okay. So electric field will apply, right? Electric field in reverse bias case. Okay, when the diode is in reverse bias. So in reverse bias, so electric field applied. Electric field applied. That because of that, the minority charge carrier, minority minority charge carrier, minority charge carrier, minority charge carriers accelerate. Okay, because electric field is applied, right? So in that case, minority, because in reverse bias there would be minority charge carriers, right? So these charge carriers get accelerated. Okay, accelerated, gets accelerated, and because they get accelerated means there would be collision among them, right? So that means collision, and collision means in depletion region electron hole pair will generate. Okay, so depletion in depletion region electron hole pairs generated. Okay, so this is this one. Okay, so electric field will apply electric field. Because of that, minority charge carriers accelerated, and then there would be collision between them, and due to that, in depletion layer the electron hole pairs generated. Okay, the electron hole pairs will get generated. Okay, and then the current will flow, right? So in that case, what will happen is, in that case, in that case is in that case this T will increase, right? If we increase the temperature, okay, if we increase the temperature, so means there would be more collisions, right? More collisions means, so if it increase the temperature, the collision will increase, right? Collision will increase means conductivity decreases, and conductivity decreases means resistivity increases. Okay, so this will be the case. And here something missing, let me check. Covalent bond and electron hole pair and tunneling. This electron hole pair generated, and here this one, guys. This means there would be tunneling. Okay, tunneling. Okay, and here and if we increase the T in case of Zener breakdown, covalent bond, the covalent bonds break, covalent bond break will increase, right? And that means electron hole pair increase, and that means conductivity increase, that means resistivity decrease. Okay, this is the case. So this is the general breakdown. Reverse bias, depletion layer width increase, strong electric field generated, potential barrier increase, and because of that covalent bonds break. Okay, then electron hole pair generated, and there is a tunneling. And if you increase the temperature, then the covalent bonds break. The covalent break, more number of covalent bond will break, right? So means the covalent bond break will increase. So that means electron hole pair will increase, and that means conductivity will increase and resistivity will decrease. So in similarly, in case of avalanche breakdown, electric field is applied, minority charge carrier accelerated, and there would be collision because of acceleration, right? And then depletion layer region, electron hole pair will generate. Okay, and here, because if we increase the temperature, okay, it means there would be more collision. More collision means conductivity will decrease and resistivity will increase. Okay, guys, so now I'm going to solve questions. Okay, so question is, So very good questions, guys, which I'm going to solve. First question is, okay, so this is the question. This is RS, okay, IS current. This is IZ current. IZ current. This is RL, okay, and this is IS, guys, and this is IL. Okay, this is the output voltage. This is this is equal to output voltage V naught equal to ILRL. Okay, ILRL. Okay, ILRL. This is V naught. So this is not question. I'm explaining the circuit for Zener diode. Okay, so this is the battery. Okay, this is resistance. So here this is a Zener diode, guys. Okay, so Zener voltage is suppose VZ. Okay, VZ is Zener voltage, and V output is ILRL. Okay, and this is RS. Okay, so here we know IS equal to IZ plus IL. So IS equal to IZ plus IL. Okay, very important one. And also IS equal to IZ minimum plus IL maximum. Okay, and similarly IS equal to or IS equal to IZ maximum plus IL minimum, important one. Okay, so IS equal to IZ max and IL minimum. Okay, here IZ minimum, IL max, and IZ max, IL max. So these are important formula, guys. Okay, you need to note down. Okay, and also, guys, the important point is this one. If V naught, that is equal to VZ. Okay, if V naught is that output voltage is less than Zener voltage, it means diode is off, guys. Okay, diode is off, because if V output is less than VZ Zener voltage. Okay, and if V output is greater than VZ, V output is greater than VZ, V output is greater than VZ, that Zener voltage. Okay, so in that case, diode is very important one, guys. You need to note down. Diode is on. Okay, diode is on. Okay, so if V naught is less than VZ, diode is off. If V naught is greater than VZ, diode is on. Okay, this is very important point, you need to note down. Then you can easily solve questions. Okay, so this is the circuit of Zener diode, and this is how so this is the concept for Zener diode. Okay, so now now we can easily solve question using this concept. Okay, so the question number first is, we have been given the question. So question is this one. Okay, this is 16 volt. This is RS. My apology. It's IS, and this is RS. This is IZ. Okay, this is RL, and this is IL. IL. Okay, and there is a V naught, this one. Okay, V naught, and this is equal to IL RL, right? This one. So V naught is given here, guys. Even V naught is given. V naught is given, that is 12 volt. This is 16 volt. Okay, this is IS. This is IZ, and IL is given, guys. Okay, IL is given. IL is given. The range is given 0 to 200 milliampere. Okay, this is given 0 to 200 milliampere. 0 to 200 milliampere. This is given, and we have to find RS, and RS we have to find. Okay, so this is the question, guys. Okay, IL is given and RS is given. IL is the range is given 0 to 200 milliampere, and RS we have to find. So here we know, guys. So I have already explained this one. IS is going to be, or IS max is going to be, IS is going to be this one. IZ minimum plus IL maximum. IL maximum. Okay, this is going to be IS maximum. Right? I have already explained here this one. IS is IZ maximum and IL max, or IS equal to IZ max and IL max. So here, because we have been given this range, so IS is going to be, or IS maximum is going to be, IS maximum is going to be, IS maximum is going to be this one. IZ minimum and IL max. IL max means this, because total current is this one, right? So IL max is going to be, this is the range given. So IL max we can write 200 milliampere, and IZ will be 0 milliampere, right? This is the range. So this is 0 plus 200 0 plus 200, right? So this is going to be 200 milliampere, and there is the IS max. IS max we have got it, right? So since IZ minimum is 0, okay, so IZ minimum is 0, guys. Okay, so this is the range. IZ minimum is 0, so that's why this IL is max, that is 200, and so I max is 200 milliampere, right? So now we can use in this loop we can use this one KVL, right? KVL we can use it. So by KVL, this is going to be 16, this one 16 minus IRS, this one IRS IRS minus VZ equal to 0. VZ is given, guys, that is 12 volt is given. VZ is given 12 volt. Okay, VZ is given, that is 12 volt. Here VZ is given 12 volt. Okay, so in this circuit if we use KVL, so this is 16 minus IRS minus this one. So this current is 0, right? IZ. So in this circuit, this is going to be 16 minus IRS minus VZ, right? 16 minus IRS, this current is going to be 0. So current, this voltage across this is VZ is 12, right? So this one 16 minus IRS, and this is 0, so this means this voltage is 12, right? So this is going to be okay. So from here we can get value of I, value of RS, because I we have found it, right? Because I is this I max is IL, right? I max, this is max, we have already find this 200 milliampere. So this is going to be 16 minus RS in 200 RS, 200 is IL, 200 RS, 200 RS minus VZ is 12 equal to 0. So from here we can get value of RS equal to 4 upon 200. Okay, 4 upon 200, and this value is going to be this one. This is milliampere. Okay, so this milliampere means this is going to be 4 upon 200 into 10 to the power minus 3 ampere, right? So this is going to be 20 ohm. 20. This is the answer, guys. Okay, this is the answer. So we have got the value of RS, right? Simple question. Next question number 2. Question number 2. Question number 2 is this one. This one. This is 1 kilo ohm. 1 kilo ohm. This is 16 volt. This is 10 volt. So this is VZ. Okay, and RL is given. 1.2 kilo ohm. 1.2 kilo ohm. Okay, and we need to find out V naught. V naught means IRL. This V naught we need to find out. Okay, V naught we need to find out. This one IRL. V naught we need to find out. V naught we need to find out, and options are given, and Vz is given 10 volt, guys. Okay, this one. Vz equal to 10 volt. This one. Okay, and options are given. Option A is 10 volt. Option B is 3.7 volt. Option C is 8.7 volt, and option D is 9 volt. Okay, so this is the question given, guys. Okay, we need to solve it. So here we need to understand important thing. So we have to find this V naught, guys. Okay, so this is very important point you need to write. So for getting this V naught, right, this one V naught, and we have been given this values, right. This point is remove the Zener diode. Remove the Zener diode. Remove the Zener diode and check whether check whether diode is on or off. Okay, on means I have already told you. On means this one. Vz V naught should be greater than Vz, and off means V naught should be less than Vz. Right? So we have to just remove the diode, and we need to check whether it is diode is on or off. Okay. So in this question, so because we need to find V naught, right? So we'll remove this and to check the V naught value. Okay. So this is going to be, figure is going to be like this. After removing diodes, so this will be like this. This one. This is RL. This value is 1.2 kilo ohm. Okay, this is 1 kilo ohm. 1 kilo ohm. This is 16 volt. Okay, so we have removed this, means this will become open circuited, right? Now we'll use this KVL here. So in loop, because we need to check where we need to remove the diode for checking whether its diode is on or off. Okay, so with this we can find out by knowing the value of V naught. We'll find the value of V naught. If V naught is greater than Vz, then on. If V naught is less than Vz, then off. Okay, diode. So in loop KVL is going to be this one. 16 minus, suppose current is I. Okay, Is 16 minus 1 I, that is I. Okay, I into 1 you can say, and minus I into RL is this, right? 1.2 equal to 0. So from here, value of I, that is we can write 2.2 I is going to be equal to 16, and that implies value of I is going to be this one, 16 upon 2.2, and that value is going to be 7.3 milliampere. 7.3 milliampere. Okay, 7.3 milliampere. this one 7.3 milliampere. Okay, so now we have removed it and we've got the value of V naught, right? Sorry, this is 8.3, guys. My apologies. It's 8.3. No, it's a 7.3. It's correct. 7.3. So now so this is the I we have found. I means IL, because this is open circuited, means current will be same, right? I equal to, that is IL you can write. So now V naught is going to be ILRL, right? So IL is 7.3 into 1.2, and this value is going to be 8.7 volt. Okay, 8.7 volt. Now you can check. V naught is 8.7 volt, and in actual this Zener voltage is 10. So we can see here V naught is less than, because it is 8.7, less than Vz. It means diode is off. Okay, and so we have got the value of V naught, right? 8.7 volt. So we have to find V naught, right? V naught. So 8.7 volt, option C is correct option. I hope guys you have understood it. Okay. Next question. Next question is, so we have this question. This is like this. RL is 5 kilo ohm is given, and this is 3 kilo ohm. Okay, and this is 16 volt, and Vz is given, this Vz Zener voltage is given, that is 10 volt, and we need to find out V naught. V naught means IRL, right? ILRL, right? V naught we need to find out. Okay, options are given. Option A, that is 10 volt. Option B, that is 8.7 volt. Option C, 3.2 volt, and option D, 12 volt. Okay, so this is the question, guys. Okay, so here we need to find V naught, means we'll remove this. Okay, for checking whether diode is on or off, right? Then we can find V naught. I have already explained. So I'll write directly. So we will check whether Zener diode is off or on by removing the diode, by removing the diode. Okay, by removing the diode. So so we are going to check it, right? So we'll remove it. So I'll make a diagram in next page after removing the diode. So this diagram is going to be like this. This one, and this is diode is removed, open circuited, right? This is 3 kilo ohm. This is 5 RL is 5 kilo ohm, and this is 16 volt. Okay, so by KVL, this is going to be like this, right? This one. This is by KVL 16 minus 3I. Okay, current is I, suppose, and minus 5I equal to 0. So it means 8I equal to 16. That implies I equal to 16 upon 8, that is 4. Oh, sorry, 2 milliampere. Okay, because it's volt upon kilo. Okay, so now we'll find V naught. So V naught equal to IL into RL. So this is IL, guys, because this is same current, right? IL. So this is going to be IL is 2 into 5, right? So this is 10 volt. Okay, so now we can see V naught is 10 volt and the Zener voltage is 10 volt. Means both are equal. Both are equal means diode is on. Okay, so since V naught equal to Vz, okay, that is equal to 10 volt implies diode is on. Diode is on. Diode is on. Okay, diode is on. So diode is on. Okay, so option the V naught value is 10. Okay, so which option is matching? That is 10. Means option A. Next question, guys. Next question is, this one. 1 kilo ohm. This is 3 kilo ohm, and you need to find out V naught. Okay, and the Zener diode Vz equal to 10 volt, and this is 60. Okay, so you need to find V naught. So means we will remove this diode. If you remove this diode, means this will be open circuited. Now I'm going to solve it directly. So this is going to be 16 minus, in this loop, because it is going to be open circuited, means 16 minus 3i minus I equal to 0. So from here 4i equal to 16, that implies I value is 16 upon 4, that is 4 milliampere. Okay, 4 milliampere. So from here we can find V naught. V naught is going to be this is IL plus RL, right? IL plus RL means IL is the same current as 4 into IL is 1, that is 4 volt. 4 volt means this is V naught, and V naught, if we compare V naught is less than Vz, means diode is off. Okay, since V naught is less than Vz, this is 4 and this is 10, right? This means diode is off. Diode is off. Okay, well guys, so before ending the class, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, and also guys, share my details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay guys, thank you so much. Bye now.